Okay, so ladies and gentlemen, for the final session, we're going to be expanding on what you've just learned in discrete event modeling and taking it to the service delivery context in a way that's coupled with population health. Much of this coverage is motivated by your very helpful feedback that many of you had expressed interest in some service delivery components. That was one of the dominant themes of feedback. And so we really wanted to make you aware of some of the options within agent-based modeling, within AnyLogic in particular, for pursuing service delivery needs. Kurt had very helpfully exposed you some of the basics of discrete event modeling. And discrete event modeling is a very powerful tool for crisply characterizing resource-limited workflows in which there are defined entities flowing through whose waiting times, disposition is determined by availability of resources and this workflow. All of what we saw in the last session could in principle be captured with agent-based modeling. You could in fact have an agent-based model where someone's progress through that system was kept track of, perhaps by a state chart, for example, what state they're in, and progressing from one state to another would require assignment of a resource to them, and reaching a certain state, they might release the resource. You might capture some quite sophisticated timing logic, just like you did in that previous model. But the amount of mechanism that would be needed in that agent-based model would be considerable to record that. There'd be a lot of opportunities to make mistakes, and it would take quite a bit of effort to have that logic for assigning resources and letting go of resources. And suffice it to say that it would not be advancing your modeling understanding to have to do that manually in an agent-based model. So discrete event modeling really fits a very nice need within a very defined set of problems. Problems where the resource availability, resource placement has impact on very defined workflows with defined entities flowing through them, and where we're interested in outcome measures like waiting times, waiting lists, throughput, etc. System-wide service interests. But it's worth reflecting on what a model like that is not capturing. The individuals flowing through that system, which were called, in this version of AnyLogic, agents, but are traditionally referred to as entities, they're a very distinguished class of beings in this model. They are held at quite some distance and in contraposition to resources. There may be mobile resources. There may be resources with a degree of agency, things like doctors, nurses, physiotherapists, physician's assistants, etc. But those resources are involved in responding to the needs of entities. And there's little interaction between those resources other than to make possible the progress of those entities. Yes, we can keep track of a certain amount of information about that resource availability and resource usage, but in terms of kind of resource entity interaction, there's not much avenues for really sophisticated interaction between the two. You can kind of force fit in some aspects of, having particular agents interacting with resources on a persistent basis, developing relationships or what have you, but it's not really easily done within the framework. And a lot of that's because the framework is fairly rigid in its distinctions between resources on the one hand and entities on the other. But more than that, ladies and gentlemen, that framework also doesn't provide too much in the way of entity-entity interactions, with one big exception. Entities interact with other entities in that model that Kurt showed you in one very, very central way. They keep each other waiting, right? Me being in an X-ray machine means that you're not in an X-ray machine, in that X-ray machine right now. You can't be there. My being bound to this doctor means that you can't be bound to this doctor right now until I'm done. So the entities do interact in a very specific way by starving each other of resources. But in terms of transmission of attitudes, knowledge, belief, in terms of transmission of pathogen, there's not much avenue for capturing that in a really neat way in these models. And the model secures some real economy of expression by not having to deal with those issues. But the point is that there's limitations to what you want to use that modeling to do. There's problems where it's exquisite, it's just beautiful to use it for, and then there's problems where it encounters challenges and it's more difficult, and then there's problems where you don't want to use it. Another example is when you have workflows that aren't really that well defined, where the rules are not that clear, where the rules are being set by the agent's interactions or what have you, where you can't neatly map out those workflows. You're going to have challenges representing them with those entities. But for a very defined class of problems, it's exquisite. And that class of problems emphatically includes certain well-defined service delivery needs that are very common in healthcare. Jeff talks about how discrete event models, once you go beyond the ER with fairly defined processes and you start going to the wards of the hospital, it tends to become very cumbersome, very, very complex. There's complex rules involving those wards, which have patients from one ward being placed into another ward under certain circumstances. There's coordination needs between multiple types of physicians around patients, and it doesn't fit really neatly into the picture here that we've seen. But for certain subsets of that, for a clinic dispensing vaccinations or a simple GP clinic or what have you, it may be a really, really nice characterization of what's needed. So, ladies and gentlemen, I would like to share with you one of the things that I'm most excited about modeling going forward, dynamic modeling going forward in general, and about AnyLogic in particular, which is its ability to bring together these two types of individual level modeling, to wit, agent-based modeling and discrete event modeling, to really couple together needs that are a good fit for agent-based models with needs that are a good fit for discrete event models, playing to the strength of both. Okay? Ladies and gentlemen, I would like to build up a model that's going to illustrate that, but it's going to illustrate, as IM want, some additional features too. It's going to tie in an additional component of AnyLogic that we haven't really plumbed, but which is important, which is spatial environments. People being embedded in a spatial context. We've already seen a number of cases of network context, which is indeed an important mediator. But spatial context is also of central interest for a lot of problems. Tomorrow, in this very room, we will be exploring GIS models where people are situated in a space that's informed by geographical information. The placement of certain resources is dictated by GIS databases. But AnyLogic also has the ability to represent broader spaces in a way that's quite rich and that can be quite insightful. And we're going to be taking a look at that today and then building on it tomorrow. So, with your leave, I would like to now start a model that will explore these issues. Okay? Time is short, and my guess is we'll finish up a bit of it tomorrow morning as well before we go into the GIS. Okay, so I'd like you to start a new model. File, new model. And maybe what I will do